for improving machine learning and artificial intelligence investment. My name is Tim Cross from WSP New Zealand, and I'll be your convener today. Before we start, a few housekeeping items. Our presentation will run for 45 minutes in total, allowing time for your questions. Please write your questions in the questions box in the GoToMeeting control panel during the presentation. And if you're a live webinar attendee, our presentation is available for download in the handouts box, including the Austroads report and quick reference guide, which we will refer to throughout the presentation. Also, watch out for QR codes throughout the presentation that will connect you to our Austroads project page. Before we start, acknowledgements. Austroads and WSP acknowledge the Australian, Aboriginal and Torres Strait Islander peoples as the first inhabitants of the nation and the traditional custodians of the lands where we live, learn and work. We pay our respects to elders past, present and emerging as they hold the memories, traditions, culture and hopes of Aboriginal and Torres Strait Islander peoples of Australia. Austroads and WSP also acknowledge and respect the Treaty of Waitangi and Māori as the original people of New Zealand. Our presentation will open and close with karakia. These are Māori incantations and blessings that are shared to encourage connectedness and focus in our meetings and are widely used in New Zealand in meetings like ours. I'm now going to share with you an opening karakia in Te Reo Māori with the English translation to the right. Te hui whaia te mātauranga, kia marama, kia whai take nā mahi katoa. Tu mahia, tu kaha, aroha atu, aroha mai, tātou kia tātou katoa, tihei Māori ora. Now on to our speakers today. It's a great pleasure to welcome Ross Guppy. Ross is the Program Manager Transport Infrastructure for Austroads. He has over 39 years experience in the road and transport infrastructure sector, including 28 years with the Queensland Department of Transport and Main Roads. Ross currently chairs 5 Austroads task forces covering asset management and more specific technical disciplines of bridges, tunnels, pavements, and project delivery. Good morning, Ross. Thank you for joining us today.
Good morning, Jim, and good morning, everyone.
My colleague David Rawlinson is WSP Digital Australia's Principal Data Scientist. Dave has worked in both research and applied AI and machine learning for approximately 20 years, having held roles in both academia and industry. Greetings, Dave.
Morning, Tim.
And introducing myself, I'm WSP New Zealand's Principal Business Intelligence and Insights Manager, Thought Leader, Project Manager, with over 25 years experience in infrastructure, asset management systems and data. A warm welcome from all of us to you. Now onto our agenda. We're going to cover today initially an introduction to Austroads and our project. From there, give you some insights with regards to what we have discovered as really a great machine learning opportunity. And from that opportunity, the research that we have undertaken, the overview of the case studies that we've delivered for Austroads, and then the methodology, which has been the critical part of the total picture. How can we actually improve the chances of successful investment in AI and machine learning? And then a wrap-up summary. Over to you, Ross, to give us an introduction to Austroads.
Thanks, Tim. First, I'd just like to start a little bit about Austroads and who we are. We are the collective of the Australian and New Zealand transport agencies. We represent all levels of government. Our members are the transport agencies both in New Zealand and each Australian state and territory, as well as the National Local Government Collective and the Commonwealth Government of Australia. Our members collectively manage close to 900,000 kilometres of roads, valued at more than $250 billion Australian, and this is the single largest community asset in Australia or New Zealand. We develop research-based standards, operational policies for construction and maintenance of roads, bridges, traffic management, road safety, driver licensing, vehicle registrations and road freight, just to name a few. We also represent Australia on the World Road Association. So next slide, please. So I'd like to acknowledge the team that delivered this project for Austroads. One of our key processes in everything we do is the involvement of our jurisdictional members in project working groups and project steering committees. In particular, I'd like to thank our project manager, Chin Dong from Main Roads, Western Australia. He was the driver for getting this project onto our program in the first place and has managed it really well since then. Finally, of course, I'd like to acknowledge the WSP team in Australia and New Zealand, who were led by David Rawlinson. Next slide, please. So why did we undertake this project? Well, we know that evidence-based decision-making is crucial to achieving good pavement asset management. We know that managing these assets can be an expensive, ongoing process, and the quality of decision-making has significant impacts on budget and the level of service provided. So to achieve this, traditionally, many agencies rely on highly skilled asset managers to deal with and understand these complex multi-criteria analysis processes. We think that the use of tools that support improved decision-making has a significant potential to create significant efficiency savings for road management authorities. And wouldn't it be useful if we could capture and maintain that corporate knowledge and historical practices and release that, reduce the reliance on the individual experts, and certainly in Australia, a lot of those are nearing retirement age. So what about effectively managing the ever-increasing data quantity and the complexity and understanding the implications of poor quality data on the application of machine learning or artificial intelligence uptake? So look, to develop and validate this methodology, we undertook 2 case studies using data from 4 of the Austroads member agencies, and WSP team will talk more about that in detail later on. So we'll go to the next slide, please, Tim. So lastly from me, just some context. You've all heard, no doubt, about the broader issues and possibilities around machine learning and how it's come to the forefront of today's technology. We know that this can be a highly technical and sophisticated topic, hence we need some form of guide to help practitioners navigate this space. We also know that many people see this as a new world that is exclusive to the tech savvy, and we need to understand the value proposition and learn to work together collectively. So we can all understand how to practically work in the asset management of pavements and how that can achieve success, and we can all thrive. We believe this work producing this project will help managers and practitioners develop and deliver smarter use of machine learning processes. If we get this right, there is significant savings to be made. Now I'd like to hand over to Tim and the team.
Great, thank you, Ross. Certainly, as in terms of the thinking and approach, what's really important for us to recognise is that, as Ross touched on, really the increased need and request around evidence-based decisions, and that we need to work together in order to be able to bring those things together. We're seeing increased demand from local communities and an increase in the amount of available data for analysis. So as a consequence, really there's the need for us to consider a path of data, information, knowledge, investment in order to drive towards evidence. And a case for us as we go through that, that we are talking about quite significant large amounts of data with a large number of evidence-based decisions required. The example here for pavement asset management in Australia, the total, if we consider in particular for Victoria, the paved network, this is around 170,000 kilometres or lane kilometres, which in every case, if we were to consider the decisions that a typical asset manager would have to make around, let's say if there were 6 different treatment selections that they could make with regards to managing every 100 metres of pavement, then we're dealing with something on the order of 40.7 million business decisions that need to be made with every round of analysis and work and investment. And this is an enormous amount of decision process. So if there is any way that we're able to utilize technology to simplify this, then we should definitely be going ahead with that. Our objective should always be, in the case of where we can use use the computers and systems to reduce the administrative load on our asset managers and our engineers, and ultimately allowing our engineers to do more engineering and less administration. So this is the value of the technology is really in our ability to be able to bring this to engineering sectors and to just simplify in process. So really a great opportunity for machine learning arrives very much when we consider investment in road. And just some overview stats here with regards to if $1 million is invested in the Australian road construction industry, then we're talking 7 workers being employed. We're talking 2.9 million output in contribution to the Australian economy, and 1.3 million of value added to the Australian GDP. So it's a very compelling case to want to invest more in the development of new roads and the maintenance of existing roads. Certainly, it's a case for us within the engineering sector that we have a number of principles and models in existence already that are already well proven that can be adapted directly within these styles of machine learning and AI. Really, because we have knowledgeable practitioners in this space, we know that we're building on a space of trust. We recognize that there is a huge complexity with regards to modeling of this type, but in all, if we're able to recognize those key principles, apply them technically within machine learning environment, we're able to prove the value and actually deliver those administrative savings to the sector. And this is applicable not just to road, but right across all engineering sectors. I'm now going to hand over to Dave to provide further insights around our project and how we approach that directly for the road sector. Thanks, Dave.
Thanks, Tim. So if you remember, Ross introduced the project and he showed you this slide which outlines the goals of the project. So it really had 2 parts. Firstly, to develop a methodology for creating and delivering new AI/ML use cases in pavement asset management. And so these are inherently research and development projects. And to prove that the methodology is one that you can actually work and provide benefit, we had to sort of test our own methodology in our own use cases. And so that was the motivation for adding to actual new projects to our project. And so I'm going to talk about the 2 use cases first, and then we'll talk a little bit about the methodology that we developed. Thanks, Tim. So the first case study looked at reproducing expert project identification decisions. So in this context, a project consists of treatment applied to a section of road. And we looked at data sets from 4 Austroads member authorities, predicting 6 different treatments over 4 future time horizons. And initially, we asked the machine learning model to generate treatment suggestions, and then we clustered those together to form projects that will be ready for further development. Next slide, please. The project was broadly successful in that we found that all of the member authorities whose data we obtained did have data to enable machine learning models to replicate some of the decision processes of a pavement engineer. And on further analysis, the model behaviors were consistent with pavement engineering principles, so they made sense. And we also looked at trying to develop a sort of universal, one-size-fits-all, generalizable machine learning model that would be able to be applied to other road networks. But in that, we found that the differences in the network characteristics, the condition measurements that were available, and the decision-making processes all meant that it wasn't possible to develop a single model at this time, although this is something that may be possible in the future with increased standardization of data collection and processes. Next slide, please. The second case study looked at multi-criteria funding allocation scenarios, and specifically the breakdown of funding between freight and non-freight routes and metropolitan versus regional routes. And what we wanted to understand is the implications of different funding breakdowns on overall network level of service and the level of service of those different subsets of the networks. Next slide. This case study was actually really successful in that we found that with small additions of new tools, we were able to really help people understand what was achievable within the budgets that were already available. And we found that there were some outcomes that were quite different to the outcomes already being exploited, but with potentially, you know, better ability to customize that to sort of tailor the needs of different priorities at different times. Really excitingly, the methods were very compatible with the existing pavement management system that are widely used already by many Austroads member authorities. And so adopting some of the methods used in this case study would actually be quite easy and straightforward for many member authorities. So this is a pretty exciting outcome. I think that a lot of people could benefit from this straight away, and for this reason, both the code from the first case study and this case study are all available on Austroads GitHub, and the link is there on the page. Okay, next slide. So at first I promised to sort of talk about the two case studies, but remember one of the sort of main objectives of our project was to develop new AI/ML use cases. And so now I'd like to talk a bit about that methodology that we developed. We didn't just want to sort of provide a sort of guide that would then sit there on a shelf, but we wanted to provide practical resources that would actually be useful for, you know, member authorities and project teams and really anyone who wants to develop a new AI/ML project, so answering a new research and development question. The problem is that this historically has a high failure rate, which means that a lot of projects start and they do perform some activities and they, you know, probably produce some outputs, but the standard that we're looking for is actually making it for production, making it to sort of everyday use and, you know, being integrated into business processes. And that's quite a high bar and doesn't always work. So we looked at, well, what can we do to try and increase the probability of that project's success? The approach that we took was to write a quick reference guide, and I think you'll find in the handout section of this report, you can download that document. It's also available via the QR code for people viewing later, the link on this page. And really that distills all of the content in the report down to a few, you know, handy, easy to use resources to help you firstly design a new AI/ML research and development project, and then secondly, like cheat sheets that help you to sort of work through each of the stages of the project. So our methodology really identified 5 key stages of the project, and then we produced a cheat sheet that sort of contains advice for each of those. The first tool that we created was a project development tool, and the aim of this tool is to help you define the problem that your project is tackling, the value proposition, and all of the other steps around sort of exploring and thinking about the problem in order to try and identify and understand and answer it properly. Our experience and the experience that we found in the literature is that this is actually one of the most common ways in which projects fail, is that they answer a problem or they answer a question, but they don't necessarily answer the question that would deliver something that can actually be used in the real world. And we often found that people become essentially fixated on solving a problem that they've defined, but the definition of that problem is sort of often more from circumstance rather than the problem that they really need to solve. And so the project development tool is really aimed to solve that problem by getting people to imagine that the solution already exists and then talk about how you're going to be able to adopt it and use it and the value that it will provide. Another problem that many people have mentioned to us, and you know, in the literature we can see is difficult, is how to manage AI and machine learning projects, and particularly in research and development projects, it's always difficult to manage the timeline and you know, the expenditure of resources and effort. And we recommend that projects adopt an agile methodology. And yeah, because Agile is normally used in conventional software projects, it's not always easy to see how you can apply that to research and development projects. So this resource is really about how to do that and explains sort of how to adapt those concepts to these type of projects. We also had people asking specific questions about, how do you measure progress when it's research? There is uncertainty. We don't know where we should be. So we sort of try to explain, how you can measure that and how you can make sure that you're sort of getting the progress that you need. Another question that many people had and found difficult to do, especially if you don't already have an AI or machine learning team within your organization, is how do you get started? How do you build a team to conduct a project like this? And we particularly wanted to show how small teams, even just like 1 or 2 people, a small amount of investment, you can still start on this process. You can still start, tackling some the use of machine learning technology within your existing business. And so the team builder tool really sort of tries to explain, given different scales of project and objectives and teams and resources, like which roles do you need, and explain some of the jargon around the skills and people you need to get on board. Thanks. Okay, so a cheat sheet. Some of you may not have heard the concept of a cheat sheet, but we produced a fairly long report that contains a ton of information about how we think you can best run a machine learning or AI research project. And obviously it's very hard to sort of keep all of that information in mind. And the cheat sheet is kind of like what you might produce before an exam, with just a summary of all the key points and answers as a reminder, just in one place. So they're 1-page documents that contain as much summary information as possible for you to reference quickly. We produced a cheat sheet for each stage of the project. So there's 5 stages in our methodology. The first one is about the requirements analysis, designing the project, identifying the opportunity, developing a strategy, forming that problem statement, and explaining the value proposition that you're hoping to deliver. And of course, also to mitigate risks that you'll encounter during the project. The second cheat sheet is about data collation, so bringing together all the data from your different sources, cleaning it, pre-processing it, exploratory data analysis, which is about understanding the characteristics and qualities of that data. Something that we would like to pass on is that often this takes a lot of the project time. You might get to half of the total project effort by the time you've produced a final, clean, high-quality version of your data. And we believe it's really important to recognize the value of that data. Essentially, you've invested in a process of digitization, data cleansing, uplift. The linking and integration all has a huge amount of value. And often people come asking at this stage in a project and say, hey, we heard that you've got this great new data set, and we'd like to use it for some other purpose. So it's worth recognizing that the work that you've done already at this stage has a lot of value, and that it's perfectly normal for this to be halfway through the project before you've been able to complete this task. Solution development is the third of our stages, and really the thing that we'd like to mention here is that it can be actually one of the easiest. It sounds like one of the most scary if you're not familiar with AI and machine learning models, but really if you can identify how you want to represent the problem and what you want the model to achieve, there's a fairly sort of straightforward roadmap in terms of what model or techniques you might want to use. It's also more similar to the conventional software engineering process, where we have fairly established processes for the data processing, creating a pipeline to train models, validate models, and then deliver them in production. So good software engineering starts to become relevant at this stage. And the fourth stage that we'd like to talk about is model validation and assessment. And this is you've probably heard a lot about bias in machine learning, and the risks of models that make faulty predictions or behave in ways that were unexpected. So this stage is really all about understanding to what extent the model is doing what you think it's supposed to be doing, and making sure that you can measure the performance of the models in terms that are meaningful to the end use case. So we're really tying this back to how you're going to use it in production and whether it meets the goals of stakeholders. So the cheat sheet's all about how to use various relevant tips and tricks to make sure you're measuring the right thing, and we would stress also being able to experiment rapidly and systematically. That's really key to being able to do good science. Next slide, please. And the final stage is one that we felt is often neglected, which is about outcomes and adoption. So all too often, people during the project, they think about achieving the immediate goals of the project, but they lose sight of carrying that momentum forward and delivering the project into some use in production. And it's often the case that the final form or the final use case of the project actually changes and develops during the project as you discover new things, right? That's a completely natural process, that in a research project you are going to discover new things, and those things are going to affect how your project can be used in production and how people are going to be able to benefit from it. Often this isn't just a negative thing. There's new things that can be discovered during the project that will enable new value to be delivered by it. So we really encourage people to think about, during the project, think about how it's going to be used and, how you're sort of going to get it into the hands of key stakeholders and users and actually make it a real thing and not just a piece of research that sits on a shelf. And with that, I think I'd like to hand back to Tim.
I guess what Dave was sharing earlier, I guess it's really a case for us of what we've created through this project holds keys to a smart adaptation that allows us to thrive in this new world. Very relevant to exactly what Ross shared at the very beginning. We need to be working together. We need to be working more closely and smarter. And there's a need for us to be, I guess, when we're thinking about machine learning, having a better, more controlled process and thinking with regards to investment. We can't just sort of, it's very easy to be sold the idea of advanced technology up front and seek the outcomes immediately. I guess the position of these things, we want to aim towards a more formalized process and methodology to succeed. And there is an enormous lot of opportunity within PAM and machine learning to reduce operational costs. We've got a question here from the 6 pavement sections analyzed. Did the model result in a pavement section similar to one of the original sections modeled, or was it new representative pavement sections that achieved the same performance in all areas?
Maybe I'll take this one. So to be clear, like the project looked at essentially the entire network of the 4 member authorities concerned. So there were many projects identified over I think hundreds of thousands of kilometers of road, and so we looked firstly at specifically we divided the network into many small sections of like typically sort of I think 100 meters in length, but depending on the member authority, some of them have variable length sectioning and some of them have fixed length sectioning. So when sectioning is variable length, then we sort of had to adapt to that, and we asked the model to generate 1 or more treatments for each time period for each short section. And then we performed a clustering to sort of bring those individual treatments together into a sort of overall projects where you wanted to apply like consistent treatment to a section of road that was longer. And that the clustering process, we performed a couple of analyses to see how much overlap, so intersection between the clusters generated by the machine learning and clustering versus the clusters that were essentially the original historical projects that were identified. So yeah, so in the report you can find quite a bit of analysis of the degree of overlap and intersection between historical projects and the projects that our models identified. So hopefully that answers that question.
What are the implications of machine learning on job security? Maybe you can touch on that, Ross.
Yeah, sure, Tim. I think, like everyone gets worried about better technology and how it might lose their jobs. But what we really are expecting to see is that, you're going to be continually asked to do more and more. And basically, this allows you the tools to help you make those decisions better, to give you the transparency, to give you that strength and quality of decision making. I think it's just going to mean, like you've said in some of the other slides, our engineers are going to be able to concentrate on doing more engineering and doing less of the administrative processes about proving why their decisions were made and why that's the right solution. So I think if anything, it should make your job more interesting.
There's a question that we've been having quite a lot, especially these days, has been about the the sort of advent of large language models and services like ChatGPT. So this is what people often mean by AI these days. And so people have been asking, can you use ChatGPT to perform some of these analyses, to write code, or to help you create machine learning models, or to do this, or do statistical data analysis with with a language model, with a ChatGPT style interface. And we obviously in our teams, we have been playing with these techniques quite a lot. We do use services like Copilot and ChatGPT to generate code to do machine learning and other statistical methods. And certainly it's a big speed up. It does help with the delivery of these projects, but I would also say that it's worth being cautious about trusting the outputs of the model. So if you don't have anyone who's got the ability to look at what it's generated and the methods that it says that it's doing and make sure that it's actually doing what it says it's doing, then I think you've got to be really cautious, because it does have a tendency to say that it's applied a certain method and actually it's done something else. So yeah, use with caution, but definitely there are sort of benefits available. Do we have Tim back?
Yes, I'm just on audio at the moment. Thanks, Dave. Yes, a question probably more centered to Ross. How can smaller road authorities and councils gain value from your research?
Look, I might just start by saying that Austroads itself, the board includes ELGA, which is the Australasian Local Government Association, and we work with the Institute of Public Works Engineers Australasia as well. So everything that we do is focused on the broad range of our membership. So that includes the smaller councils and local governments. And frequently when you're in situations like that, you really can't do all of this yourself. You really need to be part of a bigger team. And so you get the benefits of that. All the information we've got is available, for free on our website. And we certainly encourage as much as possible the membership of some smaller council, local government representatives in any of our project teams or any of our task forces. I think the other aspect is you can always go back to that team builder that Dave was talking about, for the benefits of small teams.
Cool, thanks Russ. I think, yeah, just another question in relation to AI generated code, Dave. How are we assuring AI generated code can be fixed or modified easily? Maybe more a conversation about, do you use AI generated code?
Yeah, I sort of touched on this earlier. Definitely, we have been using, we as in, the sort of data science team at WSP and many other business groups. We have been using AI generated code, so we've seen a lot of it. We have a whole bunch of internal processes for quality control of that, including, everyone who's using it and generating the code is sort of checking to see that it does what it's supposed to be doing at the time. And then we also have, sort of second person do a code review, and then, not just that, but if you recall the slide that I mentioned about, the model validation and bias and things like that. So we always build a pipeline of processes that enable us to sort of independently check the performance and the behavior of all of the models that we create. And so those kind of checks and balances really try to ensure that any code that we've produced is doing what we think it's doing, and and it's doing it well. But yeah, it's really having the sort of maturity around being able to measure the way that your machine learning is working is really vital to sort of getting good results out, I think.
Cool. Thanks, Dave. I guess one other, particularly in the space of AI, particular services that are now much more available, ChatGPT, for example, a lot more recent emergence. Actually, I think more so since we produced our report. So just thinking, I think to both of you, how do you think the road sector could gain benefits from ChatGPT to complement existing machine learning capability? Over to you, Dave.
Look, I think one of the capabilities that ChatGPT and similar language models provide is that finally we can really mine unstructured text for quantitative data. So we can get new data sets out of data that was previously essentially locked up in things like reports. So yeah, it may sound bad for me to call a report unstructured text, but from a sort of computing perspective, it is, right? It doesn't follow that sort of typical tabular format, so we know exactly what each number means. Instead, you've got to read the content around it to sort of understand what anything in the report is really trying to say. Language models provide that capability. So suddenly there's like a wealth of experience and knowledge locked up in reports and other documents that now we can actually extract that and start to leverage that value in other parts of the business. That would be number one for me.
Yeah, cool.
Well, I don't have a lot to add. I actually agree with that significantly. And getting access, it's one thing you might know the reports that are in your local area or that in your state or country, but you don't. Keeping track of all the sorts of information that's worldwide is really difficult. And there's lots of smart people out there doing new research and allowing you to bring that together to perhaps apply something you haven't thought about to a problem in your realm.
Excellent. Thank you both. I guess that it's just in closing. Certainly, we've got a number of other questions that have come through. We really appreciate all of those questions. But I think that pretty much wraps up for today our Q&A. What I'm going to do now is share with you a closing karakia in closing for our presentation. This is karakia whakamutunga. Unuhia, unuhia, unuhia ki te uru, tapu nui. Kia wātia, kia mama te nāko. Te tinana, te wairua, e te ara takata. Koia rā I rongo, whakairea, ake ki rongo. Tūturu, whakamaua, kia tina, tina, hui e, taiki e. Thank you all for joining our presentation today, and we wish you well in exploring more about machine learning and AI, and again, encourage you to check our resources available through the Austroads website, and certainly if you have any further questions, please reach out to us. Thanks, everyone.